All right, so my name's Justin Gravitt. I'm with ESAero, and this last presentation of the day is going to be about the work that we've been doing a little over a year, and going to be continuing for almost a full year, funded by the Air Force Research Laboratory to develop OpenVsp. So this is going to go through everything that has been added through our contract with AFRL and what's upcoming in the future. So I'll first talk about some of the previous SBIR funded efforts that AFRL and ESAero have had together that have developed OpenVsp. I'll go through all the tasks that we've planned out for this contract and give a status update on each one. I'll walk through some of the miscellaneous developments that have come through this contract as well. And then last, I'll just briefly talk about the schedule and so you can see what's coming for the rest of the year. So ESAero has been extremely fortunate to be very involved with OpenVsp over the last, I want to say, at least 5 years or so. We've had a few SBIR grants with NASA, and SBIR, if you're not familiar with it, stands for Small Business Innovative Research Grants. So ESAero is a small business, has been contracted by NASA and the Air Force and other organizations to provide improvements to OpenVsp. This is just what we've done with the Air Force prior to this specific SBIR. So we had a phase 1 with them and a phase 2. A lot of the improvements that have come over or come through these contracts have been released publicly. A few of them weren't able to. Either they included information that just couldn't be released publicly, or they just weren't finished to the level of quality that we expect from OpenVsp. But a lot of cool features in there: conformal components, blended wings, wave drag, structural modeling. So, like I said, we've been very grateful to have this relationship with the Air Force, and very appreciative of their contributions to OpenVsp, and really hope that continues in the future with additional contracts. So first, the generic cross-section editor. This is task 1.1. This is basically a cross-section that is a little more advanced than the other ones that were previously available in the OpenVsp GUI. This was initially released back in 3.19, and what it allows you to do is to have direct control over the Bezier control points that make up the spline of a cross-section. It's available for wings, fuselage, stack, body of revolution, props, and it was actually something that was available back in version 2 of OpenVsp, but we've re-implemented it and added tons of improvements on top of what was previously available. Wouldn't necessarily recommend it as a starting cross-section to use. It's kind of one of those things where you want to only use it when the other cross-section types can't get you the shape that you need. Like I said, it's the most advanced, or at least one of the most advanced cross-section types that we have. I'll give a demo of it, but there are 2 ways you can use the generic cross-section. The first is to convert one of the other cross-section types into a generic one. So you can take something like even a 4 series airfoil, convert that to a edit curve type, and then move the control points and edit them directly while keeping that same shape. The other option is to go on the XSEC tab, and where it says choose type, there's a drop down that you can change the type that you currently have to an edit curve type. That's the generic cross section. If you do that, your previous shape won't be maintained. It'll just initialize it to I believe a circle, and then you can go from there. So those are the 2 ways to use the cross section, generic cross section. Most of the time, the convert C-edit button is probably the way to go. Using a different cross section type to get as close as you can, and then using the convert button to go even further. So here we have just a lot of the features that are available in this generic cross-section editor, which you can see in the GUI on the right. So that's what's pulled up when you set a cross-section to the edit curve type. At the very top, you have a control for what shape you want to initialize the cross-section to. I think you have a circle, rectangle, ellipse, just really basic shapes to give you a starting point. You can toggle on symmetry, which mirrors the right side of your cross-section to the left side. Those are we only have right-left symmetry or no symmetry. At the moment, we don't have top-bottom symmetry or anything like that. Next to that, there's a preserve aspect ratio button. So what that would do is you can set it'll keep the aspect ratio between your width and height values that are below there. And then when you modify one, it'll keep that aspect ratio and adjust the other one automatically. There's the closed curve toggle. That basically just forces the first control point to be at the same position as the last control point. Pretty much 100% of the time, you'll always want to have that toggled on. There's also a button below that where you can view the absolute values of the control points. So right now, what's being shown in the cross-section editor in this image is the non-dimensionalized values of the control points, typically between negative 0.5 and positive 0.5 about X and Y, and then those control points are scaled by what you input for the width and height. You can view the absolute values of what those scaled control point positions are. We can convert the curve that defines that cross-section into a linear curve, a p-chip, which is a piecewise cubic Hermite interpolating polynomial, I believe. Hopefully I got that right. And the standard is the cubic Bezier. So cubic Bezier allows you to edit the control points that are not on the curve, so the intermediate control points, to affect basically the slope of the curve going into a control point on the curve. We can split the cross-section at any location, either by just clicking the split pick toggle and then clicking on the curve, or you can specify a certain U parameter value that you would like to add a control point at. U is going to be a value between 0 and 1 that wraps around the curve. That's the parameterization of the curve, which we actually have direct control of in the control point list at the bottom as well. You can use that to control how a control point lines up with control points on adjacent cross sections. So for example, your control point at the 0 or U parameter position is going to also line up with the control point at that same parameter on the next cross section. You can delete control points using the delete pick button, so that allows you to toggle it on and then just click on any control point and it'll remove it. Or you can also select a control point and click the delete button on the left side here. And I'll give a demo of this cross-section editor in a minute. So there's some API documentation available. We have full support of all the features that you see in the GUI for generic cross-sections through the API. There's an example script that's been provided. We also added in the execview GUI, which I'll show in a second. If you click on this show button that's next to where you select the control, or the cross-section type, it'll pull up a GUI that shows the cross-section, and you can add a background image there. We're working on adding the capability of having this image directly in the cross-section editor, the generic cross-section editor, I mean. That's something that has been requested by a lot of users. We know it would be a great improvement. Other things that we could do to that cross-section editor would be adding zoom and pan capabilities. So if you have a lot of control points that are spaced closely together and it's a little bit difficult to to change them through the existing cross-section editor, that zoom and pan capability would be really nice to have. The problem they have at the moment is just sort of limitations in our FLTK canvas class that we're using to plot those cross-section. But that is something that we have planned as an add-on to what we've already completed for this task. We've got a couple of other suggestions as well, so happy to hear from users if any of these or ones I haven't listed are things that they would really like to see. One option is a quadratic Bezier curve type, which would basically just set the two intermediate control points of a cubic Bezier curve to the same values. Also, we are likely going to add a curve reparameterization option. So if you are modifying the U parameter and things get a little bit messed up, we can have something that will kind of put it back to a parameterization that will work better with other tools in OpenVsp. Here I listed a couple of the best practices, and I think a couple of them I've mentioned already, such as only use this generic cross section when the more simple cross section types can't achieve the shape that you need. And if you do use the generic cross section, you're most often best off using the convert C edit button once you get the shape as close as you can. Try to keep the non-dimensionalized control point values between around -0.5 and +0.5, and then just use the width and height sliders to scale. Don't try to scale the control points by moving them to outside that -0.5 to 0.5 range. Try to keep close to that. Try to use as few control points as possible to achieve your desired shape. Similar with cross sections, I believe this was mentioned yesterday too. Try not to model excessive numbers of cross sections when you can just use skinning to achieve the shape that you need. I didn't mention this, but there's also a G1 continuity enforcement option for cubic Beziers, so that will keep the angle basically going. Let me think. I'll demonstrate it in a second, but it ensures that you have smooth corners where you have your control points that are on the curve. Now, I'll exit out of this presentation real quick just to give an example of the cross-section editor. And so I'll just add a stack. And I could change this something to like a rounded rectangle. And now, instead of going to the edit curve choice here, I'm going to show the convert C edit button, which will keep this same rounded rectangle shape, but it will now allow me to edit the control points directly. So you can either do that in this editor here, which it will wait to update until you release the control point. And then down here in the bottom, you can also edit the control points with these sliders or by modifying the values with direct input. This is the U parameter option, and you'll see if I find the right control point, it will change how the tessellation appears on the on-screen wireframe. So I go to hidden. Oops. Oh, and so this is the background image support that we have that you could pull up alongside the generic cross-section editor while you're making changes if you're trying to align it with a background image. You could also use clipping to try to line it up. There's a couple of different ways to approach it, but we are going to be working on having this editor support a background image directly in it, along with those zoom and pan capabilities I mentioned. So as I move this U parameter, you can see, if you're looking here, how that changes the tessellation. And if I bump up the the number of tessellation points or lines, you'll notice that a bit more. So that's what that does. This G1 option, where normally I can change the control point adjacent to the one off the curve individually. This G1 option will, is that the right one? Let's see. Yeah, find which control point I'm editing. So you'll notice the one that you select is highlighted. So if I click on one and then find it down here, that'll allow me to know which one I'm editing. And now you'll see when I change the slope on one side, it matches it on the other side of that control point. So that's what that G1 enforcement option is there for. I could come in, use this delete pick option, and delete any of the control points that are on the curve. And then I could go through and also split and add new ones if I'd like. You could do something similar with the use split and this split button, and with the delete button here when you're cycling through the control points this way. If I turn on symmetry, it's going to take everything on the right and just mirror it over to the left. I can convert to a linear curve type. And this is one that's not very intuitive, so just so you're aware, once you change this dropdown, you need to click the Convert To button. It's a button and not actually a label. So now that converted it to a linear, piecewise linear spline. And I still have symmetry on. If I preserve aspect ratio, you'll notice when I change the width or the height slider, it keeps that fixed aspect ratio constant. And if I view absolute, that will show you the scaled values of the control points. So that was just a quick overview. If anyone has any questions, please let me know, but otherwise I'm going to jump back into the presentation since there's quite a bit of other really cool features that we've been working on to talk about.
Go ahead and keep going, Justin.
All right, great. So the next task that we have is related to CAD export capability. So previously, before this work started, you could export untrimmed step and IGES files from OpenVsp. So what that would mean is that what you see on the screen is what's going to be exported to your CAD package. So if you have your wing going through your fuselage, it's going to remain that way. The focus of this task has been trimming those surfaces so you end up with a single watertight volume, which allows you to integrate with advanced meshing tools and just improves compatibility with a lot of CAD packages. So that's what the focus of this task has been. This is released as well, so I'll also demonstrate it real quickly too. We have support for full BREP step files. We have support for trim structural models with some limitations that I'll explain, but the support is there. We also have support for transparent surfaces, which are disks and wakes, and also negative volumes as well. And then here at the bottom, just describes the difference between how to access the trimmed versus untrimmed exports. So untrimmed is going to be through the file export menu, and they're actually all labeled as untrimmed. Trim surfaces you're going to do through the analysis drop-down menu. So either through the trim surface button or through the FEA mesh button for a structural export. So on the right, you can see examples of some of those different surface types that I mentioned earlier. So at the top, you have an export of a blended wing wake. Below that shows some negative volume components that end up punching holes through the surface, but it's still a watertight volume. And then at the very bottom, we have a structural model, so you can see the ribs are trimmed against the OML of the wing. So the two CAD export types we have are IGES and STEP. IGES only supports trim surfaces, while STEP supports the full connectivity of either manifold shell or B-rep solids. Those are two options that you can specify for the STEP export. Because it has all that full definition of connectivity, STEP can be more challenging to have exported successfully, but if it does export successfully, it's more likely to work in the program that you're importing it to. Hopefully that makes sense. But sometimes with the trimmed exports from OpenVsp, what we're doing is we're intersecting all these surfaces, calculating the intersection curves, chaining them together, creating loops to bound all the surfaces with. Sometimes that might not go right for just one surface. And if that does, the IGES export will likely work except for that one surface, where the STEP export might fail for everything. So that's just something to be aware of. If you are exporting STEP and IGES trimmed files, you're likely, or I would at least suggest, just exporting both at the same time anyway, and you can compare the results of each. There have been a lot of other improvements that have come to those sort of surface intersection algorithms through this CAD export capability, because we've needed to have really well-defined intersection curves to be able to come up with these bounding and trimming algorithms. So there have been improvements to what we have in OpenVsp for calculating the intersection curves. Like I mentioned earlier, we extended the wake modeling, which was originally in just CFD mesh, made some improvements to it, and now you can do it for CAD exports as well. So it's also available in the trim surface, which used to be called surface intersection, but it's available in that tool as well.
Justin is, due to his personality, he's pretty muted and low-key about this stuff. But let me just say that this is really exciting and incredibly cool. And he's not making nearly a big enough deal about how cool this is.
Thanks, Rob. Cool. Well, some of the limitations right now with this trim surface export for structural models, we're not actually at the moment breaking up the OML with the intersections with the internal components. So in that example on the bottom right, the wing surface itself is not actually broken into different sections where those intersections with the ribs occur. So that's something that can be improved. Similar behavior for intersections with transparent surfaces. So if you have two wakes intersecting, we're going to export the intersection curve, but we're not actually going to break the surfaces at those intersections. Similar with subsurfaces too. Unfortunately, at the moment, subsurfaces are just written out as surface curves, but not separate bounded surfaces. So some of those limitations I just explained are also things that we may be focusing on for improvements in the future. So intersection algorithms and or trimming algorithms for FEA structures, for transparent surfaces, and for subsurfaces. We've also talked about adding additional parameterization options to improve compatibility with tools such as Pointwise. Also adding some more control over things like the binary adaptive tolerance for intersection curves. That's one that is a pretty straightforward thing that we can do. So that will likely be released soon. Similar with cubic promotion or demotion of curves and surfaces, that's one that is a pretty low effort. We should be able to do that really quickly as well. Otherwise, just continuing to gather user feedback. So really appreciate if anyone has a specific CAD program that they use and they have had either good experience with the trimmed CAD export or bad experience with the trimmed export. We'd love to hear about it. There's actually a survey that we put on the OpenVsp wiki for the workshop that has a question about which CAD program you use, just for us to help collect some data and see which ones we might be more interested in focusing on. How the surfaces are split is another thing that we can improve on. So right now we're just using what you see in OpenVsp. So where OpenVsp automatically breaks up surfaces at cross sections or airfoils and at different along the W direction for fuselage. Those are exactly how they're going to be broken when you export through this trimmed CAD capability. We don't currently have the ability to change that, but that is something that may improve compatibility with some programs and ease of meshing capabilities. Listed some best practices on there, and I'll real quickly just go into a quick demo to show this capability. So let me exit out of this and pull up a new model. Oops. I'll just pull up the same basic airplane model that I was showing earlier and go into analysis, trim surfaces, and make sure I set the export set correctly. Display, that is basically just visualization options for after the trim surface tool has been run. Output is where you can set your trimmed CAD options. So there's some inputs here for how we want to name the different surfaces and curves that get written to the different layers of the STEP and IGES file. So that's what these options are there for. And then for step exports, we have this shell or BREP representation. Just a different representation that works better for some programs versus another. So could be worth trying if you're experiencing some issues. But there's also a tolerance that's just written to the step file. It's not actually used for the trimming algorithms or anything like that. I'll demonstrate wakes as well. And for that, I'm actually just going to remove the subsurface from the wing just to not complicate anything. But what I could do is I could add a wake to any of the wing surfaces that we have or wing components that we have available. And I click Add Wake. You can then change the angle and the scale of that wake as well. So if I decrease it a bit, you'll see it come in there. I'll leave the subsurfaces on the tail just for demonstration. This intersect subsurfaces is on, so those will be exported as surface curves, but they're not going to be, I'll show you, they won't be used to break the surface there. So I'll click the intersect and export button. Hopefully this goes pretty quickly. Some of the improvements we've been making should help make this a lot faster, and as you can see, that was done pretty quickly. Now I will pull up a program like FreeCAD. Did that come up? Let's see. Try that again. There we go. Oh, of course it's opening again. Open. And I think, so exported IGES in a step file. One thing I would recommend if you do perform a trimmed surface export, take a look at this console that's always open when you have OpenVsp running. Sometimes it might print out some error message that are relevant to the trimmed export. If it says something like incomplete step loop, something like that, that's usually a sign that your step file will not actually open in the program that you're trying to import it to. So just something to be aware of. If that happens, you might need to adjust your geometry slightly, simplify things. Basically means the intersection algorithms failed to trim the surfaces. But let me open this step file. And there you can see the wakes were exported. Let me try to turn on the visualization transparency. I'll do 50%. So you can see this is going to be, other than the wake, of course, a watertight single volume with the intersection curve between each component used to trim those components. So the internal part of the wing has been removed. Same with on the tail. These subsurfaces here, those are just surface curves. So those might not actually even show up in some programs, but other programs they might. So you still may be able to use them to control, characteristics of the mesh or anything like that. But this isn't two separate surfaces, an outer and an inner subsurface or anything like that. But that's the basic capability. I'm going to hold off on showing anything more, such as negative volumes at the moment. Might come back to it if there's some time at the end and users are interested. But jumping back into the presentation. So the third task that we set out for is edge alignment related, which did not have necessarily a clear focus at the beginning, but we've been discussing this recently and decided that we're likely going to be focusing on improvements to modeling inlets and exhausts. Still a work in progress in terms of what those details are going to be and how we're going to approach it. It might involve custom geometries, some modifications to the source code, some things that may be released publicly, others that may not. But this is something that's planned for a little bit later on in the schedule, but we're just thinking about how we're going to approach it and what we're going to do now. Been a few other ideas in terms of edge alignment assessment tools, so something to kind of give you an idea of how well your vehicle is edge aligned, different controls for edge line parameterization just to facilitate that type of modeling, and other things like that, but open to suggestions for this task as well. The next thing that we've been working on is API maintenance. So I'll talk about this more tomorrow about just what the API is if you're not familiar with it. But the primary focus of this, at least at the beginning, was just to provide documentation for the API, which used to be very limited. It still can be improved, of course, but the documentation that existed prior to the release of the Doxygen generated documentation was simply the source code itself. So now we actually have documentation that explains, at least briefly, each API function, groups them into kind of the tools that they're used with, provides a little bit of example code, describes the input parameters and outputs, things like that. You can see an example in the bottom right of a function that's been included in the API documentation. So that's available either on the OpenVsp website. I provided the link there. And we also provide a direct download of the API documentation for users that do a lot of development where they're not allowed to have direct internet access connectivity. We've added API support for all of the new things that we've been adding to OpenVsp. So like the generic cross-section editor, you can completely do everything you could do in the GUI through the API, similar with VSPro and everything like that. So also added new examples and test capabilities. So we've added, or we're working on adding a test suite for CFD mesh. And then the last aspect of the API maintenance task has been related to continuous integration and continuous deployment improvements. So this will and has improved how we get releases out, how we ensure cross-platform compatibility, things like that. Really streamlines the development and release process. But there are still improvements that we have planned for this. All right, and then next up here we have VSPro integration, which I'll try not to rush through too quickly, but I did cover a lot of the new features in the advanced VSPro presentation earlier. But the goal of this task has just been to continually support VSPro through the OpenVsp GUI. So we're always going to be just one step behind any new release of VSPro that gets out there. So support the integration of it with OpenVsp. Then we provide GUI support for all the new features. So that's been accomplished through a handful of new VSPro versions that have been released and then integrated with VSPro, and the GUI support has come along with it. We also support as much as we can the development of VSPro itself through some of the VMV studies that we have, primarily the master VMV script that was written through another SBIR effort a little while back. And we plan to continue to improve that script as well. Also, support API development of the VSPro integration as well. So you can continue to run all the advanced features like propeller analysis or unsteady analysis through the API as well. So, like I said, I won't spend too much time on this because I described it earlier, but just trying to point out a lot of the changes that have been made to the VSPro GUI through the funding that we've received from the Air Force to support VSPro integration. So we have the propeller representation, so you can run rotating propellers in the unsteady analysis, various flow conditions, ground effect distance, the load previous results toggle, things like that have all been done in this effort. This describes the propeller tab, the different features of it, how to set up and run in unsteady analysis. But like I said, a lot of this was described earlier. And then the unsteady tab of the results manager, where you plot the results from unsteady analysis in VSPro. Right, so the next steps with this task are going to be just to continue supporting any new features that are completed by Dave Kinney, the developer of VSPro. We've talked about adding support for some of the things that we currently don't have in there that you can do in VSPro, like complex motion, where you specify a velocity vector, acceleration vector, mass properties, things like that. At the moment, you can only do that through the command line. So that's something that is being discussed to see whether or not it is something that we want to add to the GUI as well. The next thing that we want to keep working on with this task is to improve the VMV script. There's a lot of outdated options that are still in there. It's a little bit hard to use, hard to change options, things like that. It also does not really address a lot of the advanced features that are available in VSPro. So definitely some improvements that could be made there. I'll skip the demo for this one unless users would really like to see it, but like I said, I already covered it in the advanced VSPro presentation earlier. So, and I believe the last task of what we set out to do with the funding that we had available was to improve the meshing capability of OpenVsp. So meshing in OpenVsp is used by a variety of tools like mass properties, even VSPro, CFD mesh, of course. Sometimes it's slow or it has issues with intersections. It sometimes can crash. And so this one, we've made some improvements just to how intersection curves are defined, how the meshing algorithm runs, and how. So for speed and robustness, we've made a lot of changes there. But we haven't added any necessarily new big features. So things like anisotropic meshing support or quad dominant meshing, that's something that still pending discussion. But at the moment, other features have taken a little bit of more of a priority, such as the updates to the Crosssection Editor to have that background image in there, other things like that. So if we have time, we can definitely come back to it. But at the moment, the focus is more on other aspects, but still being discussed, like I said. So one other thing that we did update for the mesh algorithms in OpenVsp, we updated the triangle intersection algorithm, so that should be significantly more robust, fixed a lot of intersection issues, and then, like I mentioned earlier, made some improvements to modeling of wakes in CFD mesh. So previously it was actually broken for blended wings, that blended wings works now. So you can go ahead and try that out. Then in addition to all of those primary tasks, there have been a whole bunch of other just miscellaneous improvements that have come out of this effort as well. So lots and lots of bug fixes, too many to even count. We've identified some improvements through static analysis and memory leak analysis. All of the old FLTK style GUIs have been updated. So you may have noticed in, I believe, the last version of OpenVsp, a couple of the GUIs just look a little bit different. So that allowed us to completely remove one of the projects in the build and get rid of a dependency, basically. So just cleaning things up, updating everything, and while going through that process, also adding new features, such as for the set editor. We've added an improved no-show and show behavior. We've added a copy and paste feature. We've added a copy sets when copying geoms toggle so that you can have on or off depending on when you copy and paste a geom, if you want the set indexes to be copied along with it. We've added some column resizing capabilities, so hopefully this is coming through on the bottom right image there. That's something that's not released yet, but has been completed and should be included in the next version of OpenVsp. Allows you to have the user resize all the different columns in the browsers that we have available. So if you have really long names of variables, anything like that, you can resize the columns and be able to identify them still. Made some changes for mesh geoms in terms of visualization features, help you identify them when you import multiple. And then a couple of other just small things here and there. But overall, lots of really good just general improvements. And there will be a lot more that will come up as we get to them. And so this is just to look at the schedule for the rest of the contracts. So we're over halfway. Still a lot more to go. We're going to be focusing on the cross-section editor, different improvements there, and other improvements for the CAD export capabilities. As I identified earlier, we're also working currently on meshing capability improvements. And then later on the line, we'll start with some of the edge alignment stuff, which, as I discussed, is going to be focused more on modeling of inlets and exhausts. API maintenance and VSPro integration, those will be continually supported as long as we're on contract for this. So a lot of exciting things coming, and excited to keep working on them. So I listed here a link to the survey that's on the OpenVsp wiki site. Really appreciate if everyone listening in has the time to fill that out. One of the things that I added on there was just what are your top 5 feature requests. Really interested to hear what people have to say. I've been trying to take notes throughout this workshop, identifying what people are interested in, but please feel free to fill that out. And I can always take it into consideration, see what the Air Force thinks about it, and if it's something that we want to add to OpenVsp. So that's all I had for that presentation. Looks like there's still some time left though, so I could show. I was planning to show at least how to do negative volumes and export those through the trim surface feature. But if there's anything else anyone would like to see or any questions people have, please let me know.
Justin,
Yeah.
I know you've got a structures talk tomorrow. Were you going to do a CAD export of structures tomorrow?
That was the plan.
Okay.
I know it is.
Tomorrow it can wait, but that's another one that you might do as a quick export but I don't want to steal your thunder from tomorrow.
Yeah, I'll hold off on that unless there's still time and there's nothing else anyone would like to see. Then I could show it here, but otherwise I'll plan for tomorrow to show that. Let me just open up a new instance of OpenVsp real quick. I'll add a stack and a pod. And so what I'm going to try to do is just place this in a way that's going to intersect the stack, just pass totally through it. And then we'll export that and see what it looks like. So I'm going to turn shading on. And let's see. Trying to get this in the right position. We'll try this out. Might be a little bit challenging. Hopefully it works, but we'll find out. Let's give it a shot. So what I'm going to do is come over to the General tab for the pod geom and select negative volume. We're thinking about adding a visualization aid so you can tell which components are selected with negative volume. But the idea here is it's going to perform a almost Boolean operation where the pod's going to cut a hole through the stack component. There might be some difficult intersections, some of the surfaces that are a little bit close together here, but we'll give it a shot and see if the algorithm can figure it out. So
before you do that, Justin, would you real quick switch the pod to a hidden view? And then would you crank the tessellation super coarse?
Yeah, in both directions.
Yep, all the way.
All right.
And so I just want to do this. You can continue, but I'll speak for Brandon. Some people are under the impression that the on-screen resolution matters when you're going out to IGES and step files. And so I just wanted you to make it very clear with this one running it very coarse that you'll still get the fully smooth step and IGES file. And this fully smooth intersection, you can even see it right there.
Yep. And yeah, I could real quickly show the display features for those intersection curves. So if you ever try to export a trimmed CAD file and an error message pops up in the console here, which in this case it didn't, so that's a good sign. But might be worth looking at the intersection curves a little bit more closely, seeing if there's any gaps or any jagged lines, things like that. If you do find them, it might be worth making some small adjustments to your geometry or even just sending them over to me so I could take a look at them. But
yeah, on that, go ahead and turn off the points and maybe turn off the boundary curves just to show some of those options.
So let's see. There we go. So that'll be just the intersection curves. Show. Yeah. So even with the tessellation of that pod cranked down to practically nothing, the intersection curve is still where the actual surfaces are, not just what's shown on the screen. So if I crank it back up, you'll see how that works out. So yeah, the surfaces aren't being discretized or anything like that when you're exporting to CAD. It's the actual surfaces themselves. So pull up the step file that was exported. And let's see here. So you can see a nice hole completely through this stack. Still a single watertight geometry. So that actually worked out really well. Aren't any surfaces missing. You could try the IGES file as well. But that's how the negative volume capability works. Cool. Well, is there any questions at the moment or anything anyone else would like to see with the cross-section editor, CAD Export, anything like that, VSPro?
None have popped up. Let's give them just a second to see if any pop up here with the lag.
Okay. Cool.
I'm really glad to see that you did this. I probably am going to be giving this a really big workout.
All right. Happy to hear how it goes. Yeah, it's not perfect, that's for sure. I mean, hopefully it works out.
Yeah, it looks great. It really does.
Cool.
You know, I have pretty complex geometry, so we'll see.
Yeah. And, you know, one of the reasons why I want everyone, if they do use the CAD Export or are interested in the CAD Export, to fill out the survey indicating what CAD packages they normally use, is that every CAD program is going to give you different results for the most part. Everyone has a different, likely proprietary import capability. FreeCAD is Open Cascade, so anything that's running Open Cascade in the background will have the same results. But we can make some improvements to possibly help with, like I said, maybe Pointwise or other tools that people use. But hoping to just hear what the main ones are.
Yeah, so we did have one question. Why not, and I'll probably answer it, but why not visualize the hole poked in it in VSP? And the answer there is that that's a lot harder than all the visualization that we currently do. When we visualize the surfaces, the solid, the full pod and the other body, those are untrimmed surfaces, and so the wireframe you see on screen is easy to generate because we run from beginning to end on everything. If you think of it like a blanket, and we just run from 0 to 1 in X or in U and 0 to 1 in W, we can traverse the whole thing. And then we have a wireframe and it's easy to visualize. When you trim a surface, you now need to generate a visualization of that trimmed surface, and VSP doesn't have that capability right now. So as Justin said, there's some ways. We're looking at some ways to visualize which component's the negative component. You can, Justin, would you go in and run CFD mesh on that?
Yeah, of course.
Brandon mentioned in the chat, if you run CFD mesh also obeys negative components. So just hit mesh and export. It should go through, do the same exact intersection, and then generate a mesh on it, and it will then visualize it with a hole.
Sorry.
And if you go to the display tab, you can for example turn off the mesh, and you'll have a view similar to what you had there in CAD. So that's the best we can do in VSP itself, and that should work. But it's actually a lot harder than it looks.
Great, thanks, Rob. One other thing to mention that Brandon actually provided me some feedback about earlier is, even if you're just doing a single component, you might actually have better results by doing them one at a time through the trim surface export, just because some programs really like to have that connectivity information in the export files. When you export through File, Export, Untrimmed Step, or Untrimmed Digest, each surface is just output to the file with no information about how it's supposed to be connected to the adjacent surfaces. In trim surfaces, even if it's not intersected with another component, it's still going to have that improved connectivity. More for step than for IGES, though. But that's just one thing to note.
We had a question that I'll actually pose to everyone on the YouTube side about what CAD programs are really good at doing fairings between components. I know Brandon has done some, I think in maybe it was NX, but doing a good fairing where you have a variable radius along the intersection, you wrap around the leading edge, but then how do you fair out? How do you blend out after the trailing edge into the body? It's tricky. So I think different CAD drivers are going to have their own favorites, and I'd like to have people say if they've got a good tool that they think does a really nice job with aerospace type wing body fillets. The community would appreciate hearing what works for them.
And I'll mention that while Justin was going through this demonstration, I went back to that example that I showed yesterday where I was using the cutter blades that I had to export into CAD, solidify, subtract from an existing model, and then spline that all up and get the intersection curves and then bring that into gridding. And the new trimmed CAD feature makes all that automatically. And I went and checked, and yes, the intersection curves are very smooth. They're exactly how they should be. And I didn't have to do anything except click a button. So productivity-wise, the improvement is fantastic.
Great, glad to hear. Yeah, and some of the things I mentioned that we are going to add to improve what's already available in this trim surface export is to actually use this curve adaptation tolerance right now. It's not actually doing anything to control the intersection curves that are exported. Those just use fixed tolerances. So this is something that we'll update. And then we'll also add some capabilities of controlling when you have cubic versus other surfaces and curves in there. So just two things that are coming up soon to improve this capability. Right, well, I think that's everything that I had to show. I could, just in case we don't get a chance to show it tomorrow, I'll just do a very quick example of the trims for structural models. Just have a basic wing. Let me close this out to hide those curves. I'm going to turn off symmetry real quick and add a structure. Click the Orient Wing button. And all of this I'll walk through in more detail tomorrow, but I'll just add a rib array. You could go in and change some of the positioning, things like that. But otherwise should probably be fine as is. Then if I just want to export the surfaces as trim surfaces, I don't need to go through the meshing process. You can if you also want the mesh results, but otherwise, as long as you have your output files set up already, you can just click Export CAD. And I then look at the files available here. I have a wing geom struct, adjacent step. No errors popped up here. So let me try out the step file. And I could have added, spars and other things like that too, but just for simplicity, just to have the ribs there. And you'll notice, on screen, if I show the full surface, we have these cutting planes that are much larger than the area that they're actually intersecting with. But all that's left behind when you export is the intersection curve and what is inside of the wing. So that's what that capability is there. Like I mentioned earlier, the wing itself, it's not broken into different surfaces at those intersections. So that's something that is a limitation right now. Just the ribs are trimmed against the OML. The wing itself is not performing any, is not involved in any of the trimming algorithms otherwise. So in the future, we might have it where, we cut this into a separate surface. This is going to be a separate surface. This is going to be a separate surface, that sort of idea. And that should help with some FEA programs that are going to be using it. But this is what we have at the moment. Happy to hear any feedback anyone has as well. All right, well, if there's anything else anyone would like to see, any questions they have, please let me know. Otherwise, that was it for my presentation. Really got to thank the Air Force many times over for supporting OpenVsp and ESAero at that. Been a lot of great developments that have come through their support. So we're really appreciative of the work that we're doing with them.